So hello everybody and welcome back. We're going to be finishing off the 2014 paper. We've come a long way. We blazed through part A. We did most of the written questions, which are part B. We just have one question left. And that's question number 3. So let's take a look and see what it says. So, Vicky starts with a list A, B, C, D of 4 digits. Each digit is a 0, a 1, a 2, or a 3. Vicky enters the list into a machine to produce a new list, W, X, Y, and Z. In this new list, W is the number of zeros in the original list, X is the number of 1s in the original list, Y is the number of 2s, and Z is the number of 3s, all in the original list. For example, if Vicky enters 1301, the machine produces 1201. Because we have 1 0 in the original list, 2 1s in the original list, 0 2s in the original list, and exactly 1 3 in the original list. Okay, so the machine just describes the list that's put into it. So what does the machine produce when Vicky enters in 2330? Okay, well, let's take a look. We'll need a new piece of paper. Is it Vicky with an I or Vicky with a Y? Vicky with a Y. Okay, and she enters in 2330. So really all we have to do is just describe the content of this sequence. So how many zeros are there? There's 1 0. How many 1s are there in the original sequence? Well, there's 0 1s. So how many 2s are? Well, there's 1 2. How many 3s are there? There's 2 3s. 2 and 2. Or, the first one and the second one. So the machine outputs, and we just read this off, 1 0 0 1, 1 2, and 2 3s. Okay. So that question got us a little more familiar with how the machine actually operates, in case the description and the example they gave us weren't exactly clear. It sort of put us in the trenches and we worked it out for ourselves. One thing I can notice right away is that the order here did not matter. Right? If we had had 3 0 2 3, it still would have the exact same output. Because all the output is doing is just describing the content, the number of numbers, rather than any particular order. So that was A part. What about B? Vicky enters A, B, C, D, and the machine produces the identical list A, B, C, D. Determine all possible values of B plus 2C plus 3D. So she puts something into the machine and it gets the same list back out. So I wonder some of the later questions we might be putting one list in and having it do like a cycle of 3 before it comes back to the original list. Just thoughts that are popping into my head, and perhaps as you were doing these, as you should be, you should always try these questions before you watch these videos. Just thought that might have popped into your head as well. So another thought that pops into my head, because we need to figure out all possible values of B plus 2C plus 3D, why these numbers? Why B plus 2C? Why not B plus C plus D or something like that? So determine all possible values of B plus 2C plus 3D. So what A, B, C, D, and we put that in, we got that back out. So the list that we got out just describes the original one. So there are A many zeros, there are B many 1s, C many 2s, and D many 3s in the original list. And you'll notice we could think of this as 0A plus 1B plus 2C plus 3D, and I bet that's a bit of the key. I before E except after C. So A, B, and C and D are not just the inputs, but they're also the description. So there, how many zeros are there? There's A. A. So if A was 3, there'd be 3 zeros in the original statement. C many 2's, and D many 3's. So the number we want to figure out, or we want to figure out the possible values of B plus 2C plus 3D, but as I already remarked, that's just 0A plus 1B plus 2C plus 3D. So it's the total number of 3's in here, plus the total number, well, not the total number of 3's, but the sum of those 3's. Right, because what's this saying? This is saying if you add up all the zeros, all A of the zeros, and you add up all B many of the 1's, and you add up all 2's and all 3's, you get this expression. Well, what is that? That's just, so some of these are zeros, some of these are 1's, some of these are 2's, some of these are 3's. It doesn't matter which ones are which and how many we have. But this is adding up all the zeros, all the 1's, all the 2's, all the 3's in the original list, which is A, B, C, D. So that's just like adding the original list. So B plus 2C plus 3D is equal to A, B, C, D. Does that get us any closer? Well, we could probably rearrange this and get other expressions like A is equal to C plus 2D, but I don't see how that narrows it down to actual values. So we use the second list to describe the first list, A plus B plus C plus D, but the first list we input could have been anything. It could have been 3, 3, 3, 3, and then we would have a value of 12, or it could have been 0, 0, 0, 1, and we could add a value of 1. But we know that this first list, no matter what the values are, they have to also be able to describe the list. So what does that mean? If I'm counting up the number of zeros and the number of 1's, the number of 2's, and the number of 3's, I'm just sort of grouping the values in the list and then assigning a number. So that means that any second list, so any list that is an output of a machine, must have a sum of 4. because I'm talking about how many zeros there are, how many ones, how many twos, how many threes. And everything in an input sequence is a 0, 1, or 2, or a 3. So let's just explain that a little bit more. So it describes the input list. How many inputs are there how many numbers are there in the first list? There's 4. So any output, the digits in the list add up to 4. Well, we know ABCD is an output. It's both the input she gives, but it's also she gets the identical output out, which is 4. So B plus 2C plus 3D, which we already said was equal to A plus B plus C plus D, must also be equal to 4, because we know A plus B plus C plus D is equal to 4. Alright, and that was what question B asked us for. So for any sort of string that describes itself, so the machine describes lists that get put in, so if ABCD and you get ABCD out, the only possible value of B plus 2C plus 3D is going to have to be 4. That's nice. You had to see that the second fact about the second list, or you would have been stuck manipulating algebra without any real gains. Tricky. All right, C part. Determine all possible lists A, B, C, D with the property that when Vicky enters A, B, C, D, the machine produces the identical list A, B, C, D. So we're just looking for all of the A, B, C, Ds that have the property we saw in B. Okay. Well, fortunately, our B plus 2C plus 3D equals 4 will help us. At least I hope. Otherwise, why did they have us do B part? So we know that this has to be satisfied. So why don't we see if we can come up with possible values of B, C, and D that give us this? So the big one right away that I see is 3D. So D can be at most 1. So the only way to make that true, if D is 1, that forces C to be 0 and B to be 1. Okay, and we know that A plus C plus D is also equal to 4. So that would mean A is equal to 2. So does 2, 1, 0, 1... Does that actually, I mean, this is a candidate sequence. It satisfies the property B plus 2C plus 3D equals 4, but is it actually a sequence that returns itself? The answer is no. I mean, there's no 3 in here, but the description says we need to have a 3. It's got 1, 0, 2 1s, 1, 2, 0, 3s. Okay. So now let's suppose D equals 0. It's 4 minus 0, but we can just leave it as 4. Oops, 0 less than or equal to C. So, I mean, C can't be 3 or greater, otherwise it would be way too big. B can't be negative. So we're just doing a little bit of casework. So if C is 2, and A is 4 minus B minus C minus D, we'll stop writing the and we'll figure out what A is eventually. 0 minus 0. So when I plug in 2020, what do I get at? Well, I've got 2 zeros. This is looking good. 0 1s, 2 2s, and 0 3s. So now we have at least one sequence that works. Alright, how about if C equals 1? Well, then B will have to be equal to 2, and A by extension will have to be equal to 1. So 1, 2, 1, 0. What does that produce? Well, we've got 1, 0, 2 1s, 1, 2, and 0 3s. Alright, and we have one more case, I think. Yep, C equals 0, then that forces B to be equal to 4. But any of our input numbers have to be 0, 1, 2, or 3. You can't have a 4 as part of an input string or an input list. So what do we get? Only 2, 0, 2, 0, and 1, 2, 1, 0. All right, that's interesting. Two little numbers that sort of describe themselves. So let's take a look at D part. This is the last part of the whole contest, so let's savor the question. Vicky buys a new machine. into which she can enter a list of 10 digits. Okay, well that will solve the 4 problem that we just encountered with B. Each digit is 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, so we still couldn't put in like 10, 0, 0, 0, 0, 0, 0, 0. That wouldn't be allowed. The machine produces a new list whose entries are, in order, the number of zeros, ones, twos, threes. So it still describes, it just describes a much bigger list. Determine all possible lists, I guess we're naming them now, L, of 10 digits with the property that when Vicky enters L, the machine produces the identical list L. Okay. So, how should we approach this? What could we do? Well, I guess we could use similar reasoning getting a B plus 2C plus 3D sort of thing going on. That'll have to be equal to 10. So that could certainly help us. Yeah. So I think doing the same B and C stuff we just did, but it'll be a little lengthier. I think that'll still give us the same sort of thing to go on. So how about we try that? A, B, C, D, E, F, G. I hope I don't have to write on the next line. H, I is the 9th, J is the 10th. Uh, 7H. 8I. It's 9J equals A plus B plus C plus D plus E plus F plus G plus H plus I plus J. So the exact same thing, just an extension of our reasoning part B. You could write it out again if you wanted to. I've elected not to. But we get the exact same sort of equation. It's just a little longer, so it's B plus 2C plus 3D plus 4E plus 5F plus 6G plus 7H plus 8I plus 9J equals 10. That's going to be the important thing. Actually, first let's note that the couple of these, J, I, H was associated to 7, G was associated to 6. These guys can at most be 1. We're trying to get a sum of 10. 6 times 2 would be 12. That wouldn't work. The first one that could be 2 or more, or at least 2, would be F, because it was 5F. So let's take a look at these guys. We'll start as we did with the first one. We started with J equal. We took the largest ones. We did D equals 1 first. How about we try J equals 1? So all the other ones have to be 0 except B. B will have to be 1 to fill in the gap. And then A equals 8. 8, 1, 0, 0, 0, 0, 0. 0, I need one more 0, and then a 1. So what does that give? How many zeros do we have? We have 7 zeros, 2 ones, 0, 0, 0, 0. We should have 1 8, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know for a fact now that j will have to be 0. So these ones are, it's steadily going, so now we're on to what if I equals 1. And then c equals 1 or b equals 2. If c equals 1, it's shaping up to be quite a long question, because then we're going to have to do h, and then that'll give a couple possibilities. G will give even more possibilities. So if c equals 1, b equals 0, a will equal to 8 again. We all saw how well that worked out. And d equals all the way up to h will equal 0. So what do we have here? Well, we have 8, 0, 1, 0, 0, D, E, F, G, H, I. And what does that give? That gives us 1, 2, 3, 4, 5, 6, 7 zeros. I'm not even going to work it out. We have 7 zeros, so it's not going to work. I don't need to work out the rest of the number. If b equals 2, c all the way up to I equals 0, and a will equal to 7. Okay, that's a little more promising because we've had 7 zeros all the times beforehand. So we have, oops, nope, silly me. I was just talking about how we have 7 for a. Right, how are we getting a? Well, we know that a plus b plus c plus d plus e plus f plus g plus h plus I plus j is equal to 10. So that's how we're isolating for a. So we have 7, 2, 0, 0, 0. Oh, that should be an h. C, D, E, F, G, H, I is 1. 1, 2, 3, 4. So we do get 7 zeros, but only 1, 1. Okay, so therefore I is going to be 0, and I bet H and G will probably also be 0. Next case, if H equals 1, so H was associated to 7. Right, so then B could be 3, B could be 1, and C could be 1, or D could be 1. Right, D was associated 3, so we already have 7 in our equation. We need to make up a difference of 3. So we'd have 3 times 1, or we could have 1 times 1 plus 2 times 1, or we could have 1 times 3. So all the way up to G would be 0. And what would A have to be? A would be 6. Yes. Okay, 6, 3, 0, 0, 0, C, D, E, F, G, H, I, J, 1, 2, 3, 4, 5, 6, 7. So that won't work because we got 7 zeros. All right, so what's our next case? B equals 1, C equals 1, and H equals 1. So that's another A equals 7. So that's looking a little better. 7, 1, 1, D, E, F, G, H, I, J. Doesn't describe itself, so we're going to say it's not autobiographical. There are 6 zeros. We're looking for 7 zeros. So our last case was D equals 1. So if D equals 1, A will equal to 8 because we need to have A plus B all the way up to J equal to 10. We have H is 1, D is 1, everything else will have to be 0. A will be 8. Eight, 0, 0, 1, E, F, G, H, I, J. So there's 7 zeros. We want 8 zeros, so L will not go to L. Okay. So how about the next one? Well, that was it for cases for H, so therefore H is 0. So how about if G equals, oh, not 0, what if G equals 1? Okay, that's the last of the big ones. And then we'll be getting into the F's. F can be 2 or 3, 1 or 2 or 0. So D equals 1, B equals 1, or E, which represents 4, will be equal to 1. Okay. So if B is equal to 4, we'll need 4 ones in the equation, so I'm pretty sure this one won't work out. A will be equal to 5. C, D, E, F, G, H, I, J. So L will not go to L. We have 7 zeros, but we need to have 5 zeros. How about C equals 2? Then what do we have? We have A equals 7. So 7, 0, 2. I can already see this not working because we don't have 2 2s. See, D, E, F, G, H, I, J. So L will not produce L. We don't have 2 2s, but this thing says we need 2 2s in the expression in order to put this in the machine and get it back out. How about D equals 1, B equals 1? Then what would we have? We would have A equals 7. Oh, I forgot there's a case here, or C equals 1, B equals 2. Wondering why we were coming up short a little bit over there. 7, we'd have, what was it? B is 1, C is 0, D is 1. Did I miss any other cases? No, that'd be all of them. Yeah, okay. Oh, do I have to go back and check for other cases? No, I should be fine. Sorry, where were we with D, E, F, G, H, I, J. Alright, we'll do E equals 1, and then we'll do the case that I just added. So I was wondering why C could only be 2 instead of why can't we have... Because you should be able to figure out the top value that C could be, and there should be possibilities of C equals anything less than that. I was wondering why there wasn't a C equals 1 in there. Okay, so if E equals 1, then G is equal to 1, everything else is equal to 0, so A is equal to 8, B, C, D, E, F, G, H, I, J. So this one doesn't work. Alright, how about the case we just added? I am going to laugh if this one turns out to be one that works, because that would be amazing that we caught that. So this is 2, then 1. G is equal to 1, A is equal to 6. So what do we have? We have 6, we have 1, we have 2. D, E, F, G, H. Oh, sorry. 6, 2, 1. Now, first I forget this case, and now I'm already screwing it up. 0, G, H, I, J, yep. We have 6 zeros, fine. 2, 2, 1. 6 zeros. We do have 2 1s. We do have 1 2. And we have 0 of those guys, and we do have 1 6. Ha! So this one does work. Okay, well, nice. Now, it's been so long since I looked at the question. Do we just need 1, or do we need to figure them all out? Determine all possible lists. Okay, so we're not done with this. So that was the last of the cases. Alright. That was the last of the cases for G equals 1. So F can be at most 2. We already know G is equal to 0, so we don't need to add them in. So A is going to be 8. And what do we have? 8, 0, B, C, D, E. F is 2. G, H, I, J. Well, we have 8 zeros. One, 2, 3, 4. No 2 5s. All right. So what happens if F is equal to 1? Then we get some cases. We get B equals 5. We can get C equals 2, B equals 1. We can get C equals 1, B equals 3. B always makes up the difference. Everyone else runs from 0 to its highest possible value. Oh, we know what that one is already. D equals 1, B equals 2. We could also have C equals 1, D equals 1. Now, that's getting to be a lot of cases. What else can we have? We can have E equals 1, B equals 1. So I think that's those cases. It's a lot of extra work. I'm wondering if there's a way to cut things down. I'm noticing that a lot of these things are ruined by not having enough zeros. So I wonder if there's a way to say that there have to be a certain number of zeros. Can't immediately think of something, so we should probably just continue on. Alright, so this one would be A equals 4. This one would be A equals 6. A equals 5. So we need a 5. Oh, that's not even 1. A equals 6. A equals 7. And A equals 7. Well, F1 tells us that one of A, B, J is a 5. So just this one and this one. Alright, so that at least cut down our work a little bit. We didn't have to write each of these out. So F equals 5, B equals 5, A equals A. Or A equals 4. 4, 5, C, D, E, F, G, H, I, J. So that one, and then we had the 5 zeros. And what exactly was that case? C equals 1, B equals 3. I can already see this isn't going to work because there's no D's. So B equals 3, C equals 1, D, E, F, G, H, I, J. So that didn't work. All right. So E can be between 0 and 2. That's all well and good. So if E is equal to 2, then 2 times 4 we're looking for 2 4s in our expression. What can we have? We can have B equals 2, we can have C equals 1, and that's actually about it. So that would give us A equals 6 and A equals 7. Not enough 4s, so we don't even need to check those. Equals 1. So how many 4s are we looking for? We're looking for 1. B could be equal to 6. by itself. C could be 3, D could, or sorry, C could be 2, and B could be 2. C could be 1, and B could be 4. D could be 2, D could be 1, B could be 3, D could be 1. C could be 1, B could be 1. And that's it, because we're at E. So that would mean A is equal to 3, A is equal to 6, A is equal to 5, A is equal to 4. Now we have too many 4s. This one, A equals 7, A equals 6, and A equals 6. Right, none of them are the right amount of 4s. So what can D be? D can be between 0 and 3. Alright, D equals 3. Well, we're looking for 3 3s. Well, we already have one, so that's good. B could be 1, and that's it. And A would be 6. So that one's a no-go. We're starting to run out of options here. But that's okay. Maybe 2 0 2 0 or something like that will work again. How about if D equals 2? So we need 2 3s. B could be equal to 4. C could be equal to 2. C could be equal to 1. B equal to 2. And C equal to 0, we already have that. So what would that be? A is equal to 4. That one's not going to work. A is equal to 6. That's not going to work. And A equals to 5. That's not going to work. How about D equals 1? We need one. We need just 1 3. B could be 7. C could be it could be 3, and B would be 1. C could be 2, B is 3. C could be 1, and B is 5. So here we have 1 3. So these might work. A could be, A would have to be 2. That's a no-go. A would have to be 5. So that one's possible. A would have to be 4. That's possible, and here A would be equal to 3. So we have lots of possibilities. So let's take a look at them. 5, 1, 3, 1, E, F, G, H, I, J. 6 zeros doesn't work. Okay, what's another one? 4, 3, 2, 1. I don't think this will work. Also, we've got 6 zeros. The last case for D, 5, 1, 1. Alright, so that one didn't work either. Even though we had a lot of candidates there for that question, we did not have enough. We had too many things that were already 0. I suspect if we keep going, we'll have too many things that are already 0 as well. Alright, we can have C between 0 and 5. So we'd have to have B is equal to 0 and A is equal to I'm just thinking this one can't possibly work out because we need with at least one 5 in there. We'd need G to be, or A, we'd need F to be 1, which can't work. But let's continue on with the way we're doing things. We need A to be 5. That's a no-go. And that's really all that we can have. How about C equals 4? We need 4 2s. None of these will work either, but we just go through them. That's not going to work. We only had 1 2. So this one almost could work. We'd have enough for 3 2s, but this is already not a 2. So B would be 4. A is 3. That's not going to work. C equals 2. B is going to be equal to 6. So if A is 2, we might have something. What do you know? A is 2. 2, 6, 2, D, E, F, G, H, I, J. That's not going to work. We have too many zeros. We needed exactly 2 zeros, but we have 7 zeros. So that's not going to work. How about C equals 1? So we need exactly one of these to be 2. So B would have to be 8, because B plus 2C is going to have to be equal to 10. Let's not lose sight of where these numbers are coming from. And A has to be 1 because the sum of the numbers has to be 10. So that's not going to work. There are no 2s. There, so now the only remaining case is C equals 0. Right? We can't have 0, 10, 0, 0. All the numbers are supposed to be between 0 and 9. So we had exactly one that worked that we almost missed, and I'm again writing it out wrong. It's 6, 2, 1, and then there's a 1 somewhere down the line. B, C, D, E, F. It was G, H, I, J. It's the only L on the list. So that took a lot out of us. But ultimately, it was just a question of length. It was just a whole bunch of cases, and we eventually got faster ruling out cases. So it eventually didn't become a challenge. It just became a can we beat the clock sort of thing if we were doing the contest. It was, do we have enough time? And I suspect that you could do things like, if you're going to assume that E and higher are zeros, you could probably make an argument that we can look at the A value and say there's too many zeros or too few zeros. There's probably a lot of little optimizations where you could rule out all the cases with E and stuff being higher, E and higher being 0, stuff like that. But yeah, so basically all we did was we extended our knowledge of Part B. So the work we did for Part B, we just sort of extended that to our new machine, the one that takes 10 different, a list of 10. So we extended that knowledge, and then we basically just proceeded as we did in Part C. And that gave us the answer that we have here, the single value for the list L. But so not a lot going on there. I suspect that there would be more math involved in trying to rule out cases. But other than that, fairly straightforward number 3, actually. And we just double checked that that's all we were asked for. Determine all possible lists L of 10 digits with the property that when she enters an L, we get the identical list L. So that does it. That's the 2014 CIMC paper, the intermediate papers. I hope you enjoyed it. I certainly hope that you tried the paper before you just started these videos, as you should be doing. And if you liked it, throw a like down on the video. If you want to, you can subscribe. I do lots of these contests, and just general more math. You can browse the channel and find other things. But until the next video, thank you for watching, and I'll see you guys again.